A transistor is a three-terminal device. It's a current amplifier. The symbol for it will look a little familiar to you because it looks an awful lot like the phototransistor that you've been using as a light sensor. In the case of a phototransistor, light shines on it's a transparent case, light gets in there, and it allows a current to flow from the collector to the emitter, and that's what you were using to detect light. The transistor, this is an NPN transistor, however, is a current amplifier instead, and you have access to another piece of the internal mechanism, which is called the base. I wouldn't make too much sense, try to make too much sense out of these words, base, collector, and emitter. They are historical and they can only confuse you. Just think of them as C, B, and E. The way this works is, just like light allowed a current to flow, we'll now call it the collector current. The collector current would flow from the collector to the emitter. Now that is permitted on the basis of a much smaller current called the base current, which also flows from base to emitter. So a small current here allows a much larger, proportionately larger current there. Now nothing's going to happen like that when the device is just sitting there in isolation, so we better put it inside a circuit. Here's a plus 5 volt and ground rail, and I'm going to put my transistor here with its collector, its base, its emitter, like this. And we're going to ask, how much is this collector current? Now you can see that if this allows any current from collector to emitter, that's going to be a current that goes like this, straight through like that. And what's going to let that, just sitting here as it is, there is no base current, and therefore there'll be no collector-emitter current too. Let me also warn you, don't think of this as being a resistor. It's not a resistor. This current that it allows through is not proportional to the voltage across it, which after all right now is 5 volts. It's proportional to the amount of current that flows in the base. So how can we get some current to flow in there through the base? One way would be to take a resistor and connect it up like that. Let's say it's a 1 million ohm resistor. How much current is going to flow from the base to the emitter? And as a consequence of that, how much collector current will there be? Well, if I knew the voltage across that 1 million ohm resistor, I would be able to figure out how much current is flowing through it, and that current is going to flow through the base to the emitter. How could I tell the voltage across that 1 million ohm resistor? For that, I need to know something about the transistor, which is that its base emitter junction here acts exactly like an ordinary diode. We've already looked at diodes, so I can imagine replacing that connection. You can see it hinted here with this arrow. I can imagine replacing that connection with an ordinary diode. And you learned that a good approximation for the forward voltage across a diode when there's a current through it is it's about 0.6 volts. There's about 0.6 volts from here to here. And that's true over here too. So there's about 0.6 volts from here, from the base to the emitter. The emitter is at 0 potential, therefore the base is at about 0.6 volts potential. And that means that the voltage across that 1 million ohm resistor is 5 volts minus 0.6, 4.5 volts or so. With 4.4 volts across that 1 million ohm resistor, there is 4.4 microamps through it. That 4.4 microamps goes in the base, out the emitter. That becomes this current, this small current, that enables a much larger current. So what's the relationship of those two? The collector current, here it is, the collector current is proportional to the base current times a factor which is called the DC current gain. It's often called HFE, and it varies from transistor to transistor, depending on the heat, the temperature of the transistor, and so on. But a very typical value for that is 100. When in doubt, we're just going to say that the current gain of any random transistor is 100. So with 4.4 microamps going base to emitter, that means our collector current is 100 times bigger than that, 0.44 milliamps.